Hi everyone, in this lecture we're going to continue the next topics in the module 6 related to structural analysis of frames and machine. Before we proceed with these discussions, there's an important concept that I would like to discuss, and it's related to two force members. Okay, so if we have a member that is pin connected at its both ends, okay, and no load is applied within the members, then we will have a two force members. Okay, and this two force member has a very unique characteristics where the connection forces at its both end are collinear. Okay, so if for example if I have this member that has an arc shape and is pin connected at B and A right here, then I know the connection forces at A and B, it has to be collinear. Okay, so if this is F, then this is F. Okay, and the directions of the forces is doesn't necessary to always to go outward from the member. It can be there can be a case where the connection forces in here are going inward to the member. Okay, however, the most important thing is that this connection forces has to be collinear. Okay, so if we can further simplify the shape of these members, let's say that right now we have a straight member, okay, that are pin connected as its both ends at A and B, right? And then there's no load applied within the members, right? So there's no load applied within the members. Then we know that the internal connection forces at A and B has to be collinear. So if this is F, then this is F. Okay, so it's similar to the truss, right? And then since it's similar to the truss, and we have learned that this F doesn't necessarily to always go away from the members, it can also go to the members. Okay, so there can be a case where this F is going to the members, such that in here we have a compression truss or compression members. Okay, what will happen if we have a force that is applied somewhere within the on the members, right? Then in here we still have the connection force, right? We still have a connection force at A and B, right, that are pin connected, but that connection force is no longer collinear to each other. Okay, so this connection force is no longer collinear to each other. Okay, perhaps it could be drawn like this. Okay, and with that I would like to discuss the next topics in here, where we will going to learn how to perform structural analysis on frames. And in here mainly we will talk about composite structures. Okay, in here is, for example, we have one structures and another structures that are connected with some internal connectors. Okay, and the main objective when we solve problems related to frames is to calculate what are the internal connection forces. Okay, so what are the internal connection forces that on the connectors that connect these two or more structures. Okay, so please differentiate between the internal connection forces and the internal forces of the members. Those are two different things. Internal forces are related to the body, to the members, and internal connection forces are related to the connectors between two bodies. Okay, and in most of the problems that we will discuss in here, the connectors that we means are pin connectors. Okay, and we have learned in module 5 that in pin connectors it allows rotation, right? It allows rotation, so there is no transfer of moment. Okay, in other words, the moment is equal to 0 at the location where there's a pin connection. Okay, since the moment is 0, the only forces that can be transferred is only shear, right, and axial forces can be transferred. Okay, right. Okay, so the problems related to frames can be divided into two major categories. Okay, the first one in here is a very unique structures. So in here we have two members, okay, members AB, right, and members BC. Okay, at member AB it is fixed at point A, okay, and then member BC is roller supported at point C. Okay, and then these two members are connected together with an internal pin or connectors, internal pin connectors at point B. Okay, so I would like to see that member AB itself, right? So member AB itself in here, okay, if I separate member AB and member BC, this is A, B, this is B, C, right? And then we have the force P1, the force P2, right? Then at A, we have the reaction forces, right? At A, we have the reaction forces AX, AY, and MA, right? At C, we have the reaction forces CY. Okay, since B is a pin connectors, it only can transfer shear and axial. Then in here we have BX, BY, and in here we have same thing, BX, BY. And note that the directions of this BX on the left hand free body diagram and then the right hand free body diagrams are in the opposite directions. Okay, such that when we connect these two structures together, these internal forces will these internal connection forces will eliminate each others. Okay, however, there is one thing that I would like to say for these composite structures. If we observe this the member AB itself, right, so if we observe the member AB itself, where at A it is fixed support, right, this structure is a stable structures, right, because it provides enough constraint to restrict the rigid body motions of the members in two-dimensional plane. Okay, however, the member BC in here with a roller support at C, here is the structure is unstable. Okay, so structure AB is stable and structure BC in here is unstable. Okay, so if you are able to identify a stable and unstable structures within a composite structures, then it will be much easier for you to start by solving the unstable structures first. Okay, so if you are able to identify which part of the composite structures are stable and unstable, then you have to start with the unstable structure first, okay, such that in the unstable structures you can apply the equilibrium equations, right, which is sum of the forces in the x equal to 0, sum of forces in the y equal to 0, and sum of the moment at any point equal to 0 to solve for all of the unknowns, okay, including the pin connection forces bx and by in here, okay. All right, and then after you solve for all of these unknowns, then you can proceed to the stable configurations. In this case is structure AB, to solve for the remaining unknowns. In this case is the reaction forces AX, AY, and MA, okay. And later we will discuss one example problems on how to apply this concept to calculate the reaction forces and the internal connection of forces of a composite structures, okay. And the second type of composite structures is a little bit different from the first type, where right now if I try to separate the members where this pin connected at B, okay, so I have this arc, right, and then at A is pin support, so I have AY and AX, and then at C is also pin support, then I have CY and I have CX, okay, and then at B I have BX, then in here I have BY and then BY, okay, and then with the external forces that is applied in here, okay, so we separate the composite structures into the left hand free body diagrams and then the right hand free body diagrams, okay. And in this case both of the left hand and right hand free body diagrams, if we just consider the structures individually without the pin connectors at B, then the structure is unstable and the structure is also unstable, okay. In this case you can start with any free body diagrams. You can start either from the left hand free body diagrams or the right hand free body diagrams. You will obtain the same result, okay. And for each free body diagrams in here, we can write three equilibrium equations, which is the sum of the forces at x equal to 0, sum of the forces in the y equal to 0, and sum of the moment at any point equal to 0, okay. The most important concepts in solving a composite structures in here is to make a cut where the pin connectors is located, okay. And remember, once you make the cut, you separate the structures into two or more components, right, and then we have to, in our free body diagrams, we have to include the pin connector forces, okay. And afterwards we can apply the equilibrium equations to each of the free body diagram, okay. For machines, typically the problems will ask you to calculate what is the internal force of the strut, link, or hydraulic jack that used to support the certain components in that machine, okay. And one thing that you have to remember in here is that the strut, link, and hydraulic jack force has a very similar properties with the truss members that we have learned in the previous lectures, okay. And there's basically the strut, link, and hydraulic jack is a two force members, okay. So it's a two force members where it has to be pin connected at its both ends, and there's no load applied within the members, okay. And a very useful tips, I guess, when you solve problems related to machines is to make a cut. Okay, make a cut at the location of the pin connections. Okay, and I guess it will be much clearer once we solve some example problems related to these topics. Okay, I think that's enough for these lectures, and thank you for listening. Please let me know if you have any questions.